Okay, ladies and gentlemen, welcome back to 4.6 review. And we're just going to do a quick review of exponential growth and decay. So when we talk about exponential growth and decay, it is extremely important that we understand what the symbols mean. So this is the quantity after a certain amount of time. Okay, so I don't know what the time is. It could be minutes, seconds, hours. Things decay differently or grow differently in life. Okay. To calculate that, though, you first got to know what the initial of anything is. How many blood cells you have. How many how many pieces of a particular bacteria you're looking at. And then this is what's really going to control the growth. It's this E part. E and then raised to this exponent kt. So when you find this constant k, then every time you plug in a time, it changes how the whole entire initial quantity grows. And that's pretty what it comes down to. So like any word problem, you got to be good with reading. If you're not good with reading, this is not going to be very successful. So reading comprehension is still the ante to play. So what this means is if we can find out what Q naught and what K is, we're ready to rock and roll. So let's take a quick look here. Okay, here's a problem from class that we discussed, and we're going to go through it step by step and just make sure that we have a very good understanding. So let's just read. It says the population of a small town decreases exponentially. Okay, so you know there's an exponential decay going. If the town currently has 8,000 residents, let's stop for a second there. Currently has 8,000 residents, so that means that your initial population or initial quantity is 8,000. Is 8,000. Our initial quantity is 8,000. So what this means is, another way of expressing this is that the quantity at 0 equals 8,000. Okay. So the time at 0 time equals 8,000. Okay, let's keep reading. And projects that 5 years the population will be 6,000. So that means what? That in time equals 5, there should be, so Q of t is 5, right? Should be equal to 6,000. So this is the equivalent to the point saying 5, 6,000. Okay, so this is that situation we're talking about, that they got to give us something that at a certain amount of time, a certain amount of quantity is there. This is what this piece of information is what we will use to find k. Excuse me. Then finally it says what population will be expected in 10 years. So what is the quantity at 10 years? So we could find this if we are able to generate this equation. Okay, so let's go back and take a look and see what we could fill in. Okay, so if we take a look at this, we know that at time equals 0, it's 8,000 people. So we know that's the Q of t, the quantity after a particular amount of time, is going to have 8,000 people times that e to the kt, and k is that growth rate. They tell us that at 5 years, 6,000 people are present. This is the piece of information we need in order to find k, because that's our job. We need to find k. So let's go ahead and do that. Okay, so when Q of t is 6,000, that only occurs when t is 5. So let's go ahead and solve. So first things first, let's divide by 8,000. Let's divide by 8,000, and we end up seeing that this gives us 3/4 on one side and 5k on the other side. Okay, really simple. Now, how do we undo an exponential? Well, everybody should be saying this in their head. Natural log. So let's ln both sides. And when we ln the right side, we ln the left side. This is the cool part. Those two undo each other and just gives you a regular old 5k, which is ln of 3/4. K is ln of 3/4 divided by 5. Yay. Okay. Now, are we done? Absolutely not, because we still got to take this k and shove it back up into my beginning part right there and figure out what the formula is completely simplified. Okay, so let's do that real quick. So now that we have this, keep that in mind because I need to get me a clean blank slate. Okay, so ln of 3/4 over 5, that was my k, and it was q of t equals 8,000 e to the kt. Okay, so let's plug our k in and see if we can finagle it. K is the natural log of 3/4 over 5 times t. Okay, now this is where we got to play with this a little bit. See this 5? We're going to use the commutative property and push it under that t. Now, why are we going to do that? Because this e and this ln want to undo each other, but things are blocking it. Things are blocking it. And what I mean by things are blocking it, that there's still this t over 5 here that we need to deal with. So recall that a to the m to the n. When we had exponent to an exponent, we multiplied the two, right? So let's use this backwards. When I'm multiplying two exponents, that's the same thing as me saying 8,000 e to the ln of 3/4 all to the t over 5, because that's what it means. We just used it backwards. So now simplify it down, guys. Simplify it down. E and ln undo each other, which everybody should say, oh, well, that's just 3/4 of t over 5. So finally, we have our equation. Wasn't really all that bad. We end up seeing that q of t equals this. And now we can finally answer their question, which their question was, what is the quantity at 10 years? Well, let's plug in 10. So q of 10 is 8,000 3/4 to the 10 over 5. And guys, what's 10 over 5? Easy. That's just 2. So we square this out, we get 8,000. 3/4 squared is 9/16. 8,000 divided by 16, guys. Well, that's just, I think 16 goes into 85 times, so it should be 500 times 9, which is 4,500. And this actually, it looks like an 8, doesn't it? 4,500. And the thing to actually keep in mind here, which is actually quite nice, is that, check it out. So at initial time, we had 8,000 people. In 5 years, we had 6,000 people. And finally, in 10 years, we have 4,500 people. Notice that it's decaying. Okay, that's what decay is supposed to do. All right, now in class, I always get this equation really quick. I just check out the answer. Now, does Resh know some special math? Correct answer, no. Resh doesn't know any special math. He's just very observant to patterns, okay? All right, so if you remember how we got this and how I always get this, is they got to give you some situation here. So let me get another clean slate. So keep your eye on the prize. You might need to rewind and see this, okay, later. So I'm going to erase this, and it says at 0, it's 8,000. Now, you could do this with any problem, but it requires you to know the initial amount. You have to know this, okay? And then at 5 years, it's 6,000. So what do I know? I know that the quantity after a certain amount of time, to figure out this thing, I'm going to need the initial amount, which is 8,000. But in here, okay, after you plug stuff in and simplify it down, something special happens, okay? And this is what ends up happening. It went from 8,000 to 6,000. So if you look at the ratio of the quantities, the later quantity to earlier quantity, it gives you this. And then, if you notice, it happened over t equals 5. So I know one time interval of change would be 5 years. Okay, so if I simplify this, we end up getting 3/4 t over 5. Notice it happened immediately. I didn't have to go through all the extra work of solving this. And I can just plug time in and answer whatever questions they have. So whether you understand it, and this is the theoretical way, or if you just know the ground and pound way, which is the previous one, you can get through these problems, okay?